So today we're doing a bit of a deep dive on a single, very specific piece of hardware. We're looking at the product page for the Aurora Multimedia DXE-CAT-RX2-4K HDBaseT receiver, and our mission really is to figure out the engineering here. We want to understand the technical trade-offs you have to make for sending high-def signals over these, incredibly long distances using HDBaseT.
Which is, I mean, it's the go-to technology for this. It lets you send your video, your power, and control signals all down one standard Ethernet cable.
Right, and this particular receiver, it's part of their Digital Extreme series. It's designed to solve that one core problem. How do you get an HDMI signal way, way past where a normal cable just gives up?
Okay, so let's try and unpack that. The whole game here is range, but distance. It always forces some kind of compromise. What's the key performance trade-off that this spec sheet highlights right away? Well, what's so interesting is the direct, quantifiable link between the cable you use, the distance you can go, and the color depth of your video. This is the choice you, as an installer, have to make. So if you want the absolute best color, we're talking HDMI 1080p at 60 Hz with 48-bit color depth, that's deep color, gives you much smoother gradients.
Right.
But that limits you. You're capped at 330 feet over a standard C-Cat5e or 6 cable.
Wait, so hang on. If I'm an integrator and I'm working in, say, an older building, you're telling me I have to choose between those really rich colors and reaching a display that's 500 feet away?
You do, absolutely. If you can accept a step down to 24-bit color, you can immediately push that same signal out to 500 feet, and that's just over a standard C-Cat6 cable. And if you need to go even further, you can use a Cat6a shielded cable. That'll get you all the way to 600 feet, still at 1080p 60 Hz, and that 24-bit color.
So the compromise is crystal clear. You're literally trading the amount of color data for more distance and better cable shielding. And speaking of limits, the documentation says the absolute ceiling here is 4K at 30 Hz.
Exactly. And that 4K 30 Hz running at 340 millihertz, that's the key. That frequency is the physical wall for this generation of HDBaseT. It's the max data rate before things start to break down. We should also probably note it's HDCP compliant.
High bandwidth digital content protection.
Yep. So it'll play nice with your Blu-ray player or a streaming box.
So we've got the signal trade-offs down, but, a perfect signal doesn't matter if the box is a nightmare to install. What did Aurora do to make this practical? This is where the patents pending stuff comes in, I assume.
Yeah, they really focused on a huge frustration for installers. All the main connectors, your LAN, HDMI, control, power, they're all lined up on one side.
That sounds minor, but in a tight rack.
Oh, it's a huge deal. It just makes for much cleaner wiring. It saves you a lot of grief when you're trying to mount it somewhere you can't see.
Okay, let's pause there because the power situation is genuinely surprising. You can inject power from either end. What problem does that solve?
It's all about flexibility. The system uses power over Ethernet, PoE, but you can power both the transmitter and this receiver from either side. So if your transmitter is stuck behind a monitor with no power outlet nearby, you can just send the power all the way from the rack up to 600 feet away.
Wow, okay. That saves a lot of time and extra wiring.
A huge amount.
Yeah.
And you get all your control signals down that same pipe, 2 bidirectional RS-232, IR, and LAN.
And for anyone out there who might be sourcing this, the commercial side is important too, right? It's TAA compliant.
That's right. So it's good for government jobs. It's also made in the USA, tariff-free, and you get a 5-year warranty, which, adds a lot of peace of mind.
So what this all really means is the DXE-CAT-RX2-4K is kind of the perfect example of professional AV engineering in action. You're carefully balancing distance against color depth while also innovating on the physical design and the power delivery to make it work in the real world.
And that actually brings up a really interesting question for the future. I mean, considering how complex it is to deliver stable PoE power over 600 feet, think about how the engineering priorities would have to shift if the standard became 4K at 60 Hz, not 30 Hz.
The data rate would double.
Exactly. The power draw, the heat, everything would change. It would force a completely new set of compromises. So, something for you to think about on your next installation design.